Hello, my name is Beth Dixon, and this is part 6 of a video series on frequency distribution and histograms. And I would like to apologize for having it to be so long, but then I got to looking, and Miss Borlaug made an PowerPoint of over 80 slides, and it just takes this long to get that information across because the information is so deep and so detailed. And speaking of Miss Borlaug, again, I'd like to thank Miss Borlaug for the use of her PowerPoints to help us with this video. Histograms can help us visualize characteristics of the data set. We have some histograms here. Histograms A, B, C, D, and E. And we're going to look more at these histograms. Histograms can tell us about the shape of data. What can that shape tell us? With these 5 examples of histograms shown, we can describe some different shapes of the data. Which histogram looks like it came from a uniformly distributed data? Data is spread evenly over all the possible values. That would be histogram D. Notice how all the heights are very uniform in frequency. Not exactly, but close, and the data remains the same as we look at it from left to right. Again, looking at the shapes. Which data looks like it came from a data set that is skewed to the right? When data is skewed to the right, it has a longer right tail. More data to the right than we would expect. In other words, the data trails off with values to the right that go on, like the Energizer Bunny. It just doesn't seem to want to quit. Look at the shape. Look at each shape. We can eliminate D. We said it was uniform. It doesn't seem to fit. That would be histogram C. Histogram C has that tail of data to the right, where the right-hand data just seems to have more data on the right-hand side than we would expect. No, the frequencies aren't high on the right-hand side, but there seems to be more of it toward that right-hand side, so it's skewed to the right. Notice that here. Clearing that question out, which histogram looks like it came from a data set that is skewed to the left? Well, histogram D is fairly evenly distributed or uniformly distributed. Histogram C, we said, had a tail to the right. We're looking for one with a tail to the left, with more of its data on the left-hand side. That would be here. Histogram E. skewness is one of the things hard for me to explain. Just remember that the direction of the tail is the direction of the skewness. That takes care of the two types of skewness. Now, what other shapes can we describe? Which histogram looks like it came from a normally distributed data? This data will be shaped like a bell. This data will be mostly symmetrical. It will have the same shape from a middle point. Looking at histograms, although histogram D is symmetrical, it's not shaped like a bell. Histogram E, we said, was skewed. It's not shaped like a bell. Histogram C is not shaped like a bell, and my bells are awful on this computer, but you can see, hopefully, that histogram B is very much shaped like a bell. One last shape then to describe, which looks like it came from a data set that's bimodal, data that has two values that occur most often. And that, of course, leaves us histogram A. It has a peak and then a second peak, and therefore most often once, most often twice, and two areas that have two peaks or occur most often. Now, for that word of caution that I've been promising since the first video. Always critically analyze your data that's presented to you. Histograms can be tricky, and the people presenting them to you can try to trick you. Never turn your brain off when looking at the data or pictures of the data. You and your thinking skills are always the best tools for that job. No computer can replace those critical thinking skills. Look at histogram A number 1 and histogram number 2 and make some quick judgments about the data that it represents. What's the difference between the two data sets? Both histograms represent the same data. Did you catch that? The difference between the two graphs is what? The difference is the value of the tick marks on the vertical axis. 0 to 7, 8 to 15, 16 to 23, 24 to 31, 32 to 39, and 40 to 48 is the same for both histograms. The height of the first one looks to be 39. The height of the second one looks to be about 37. Then 45. The next one 42. Maybe 41. Then back to 39. And then lastly 41. And that does look to be 42 if that's 41. So the heights are the same, and yet the differences between the groups are exaggerated in histogram 2. To avoid this misrepresentation, the vertical axis for the histogram should always start with what value? If histogram 2 exaggerates that misrepresentation or the differences between the groups, you should always then start with 0. That concludes this presentation and this series on histograms. Thank you for watching, and we're signing off.